So in this video, we shall see the definition of electric field intensity. We will find the electric field intensity due to a point charge and then due to multiple number of charges. In the last video, we have seen what is electric field. We have discussed about the test charge and source charge, right? So electric field intensity, this term is related to those topics only. So what is electric field intensity? It is defined as the force experienced by per unit test charge placed at that point without disturbing the source charge. We have already seen that if you're having a plus Q charge, okay, which is the source charge, it will create an electric field, right? So if we place any test charge, okay, at any point, okay, at some point, then the force that this test charge will experience, okay, without disturbing the source charge, okay, that force per unit test charge is at that point without disturbing the source charge is said to be electric field intensity. And we can express electric field intensity as E is equals to force per unit test charge means by Q naught. Clear? So here, if I write here, this E is the electric field intensity, okay? E is the electric field intensity. Okay? This is the electric field intensity. Second, what is Q naught? It is the test charge. Q naught is the test charge. And then we are having F. What is F? F is the force experienced by the test charge Q naught. It is the force experienced by the test charge Q naught. All right. So you see here the force is a vector quantity, right? So electric field intensity is a vector quantity. And always remember, electric field due to positive charge is always away and due to negative charge is always towards it. We already seen the representation and the directions of electric field. So from there also you can understand this. And if you are looking at the unit of electric field intensity, so its SI unit is Newton per coulomb or volt per meter. This is Newton, this is coulomb. All right. CGS unit is dyne per state coulomb, or you can say dyne per absolute coulomb. Okay. So these are the units we have already discussed when we have discussed charge. So this is all about the electric field intensity's definition. Now we will see the electric field intensity due to a point charge. All right. So for this, what we will consider a point A. And at this point, I'm placing the source charge Q. And at a distance R, okay, at a distance R, I'm placing the test charge. So P is any point at a distance small r from the source charge. Clear? So now you see this charge is positive, this charge is unit positive. So this charge will repel this charge. So the direction of electric field and force is always same. So since it will repel, so the direction of force is in this direction, that is away from the source charge, right? So the electric field direction is away. If this would be negative, it would be towards, because it would have attracted this test charge, right? Clear? So now what we have seen from the Coulomb's law. What is the Coulomb's law? It is giving us the force, right? We have seen the electric field intensity is force per unit test charge. So for this, first we will see the force, okay, using the Coulomb's law. So using Coulomb's law, what we will write, F is equals to 1 by 4 pi epsilon naught Q naught. That is the product of the charges by the distance between them, the square of the distance between them. And r cap is the direction. Now, what we know that electric field intensity is the force per unit test charge. So here, if we substitute the value of force, right, which is, this term can be written as K, okay, this term can be written as K. So I'm writing it to be K Q naught by, this is Q naught and into with R square, R cap. I've just substituted the value of force in this equation, okay? So from here, this 2 Q naught, okay, it will get cancelled. And you will have the electric field intensity, E is equals to KQ by R square, R cap. And this direction can be written as E is equals to KQ by R square. And you can write the direction to be, it is along AP, okay? This is what you can write. Clear? And also what you will see, the magnitude of E. You can write the magnitude of E to be equals to KQ by R square. So here if you see, electric field is inversely proportional to the, it is inversely proportional to R square. So the graph would be, you can draw the graph as well, okay? As the separation between the two charges increases, electric field decreases. So this is how you can draw. This side is the E, this side is the R. And similarly, if you are drawing for 1 by R square, and this side if you're keeping the electric field, so this would be this way. Because if the value of 1 by R square is increasing, electric field will be increasing. Clear? So this we have done only for a point charge. So now let us see the electric field intensity due to multiple charges. So due to multiple charges we are doing, then we are using the superposition principle, right? So here I'm considering Q1, Q2, Q3, Q1 number of charges are placed at a distance R1, R2, R3, Rn in vacuum. So for this, I'll consider a two particle system. Okay, suppose I'm writing here this to be the x-axis, this is the y-axis. Suppose you are having a test charge here, Q0. So if you're having your charge Q1 here, Q2 here, Q3, and Qn number of charges. So this test charge will experience a force due to all these charges. So the total or the net electric field intensity can be calculated by using the superposition principle, which says that it will be the vector sum of the individual electric field, right? The same technique we will use. So if I'm placing a charge at the point A, and this is the point B, okay? So here if I'm placing a charge Q1, here there is a charge Q2, and at this point P I'm placing the test charge. Okay, so you know from the origin, okay, this distance is said to be the position vector for R1, right? This is the position vector for the B point, right? This is R2. Clear? Now this is the distance between the origin and the test charge. Now you see this charge will experience a force. Okay, this charge will experience a force due to this. And I have already said field intensity, electric field intensity and force, they are having the same direction. So this will repel. So E1 is in this direction, right? Similarly for Q2 charge, the force that this test charge will experience, its direction will be on the other side, right? And in this way, you can consider number of charges. And the resultant will be in this side, net electric field. Clear? So now for this, what you will write, the net electric field E, it is the sum of the individual electric field intensity due to multiple number of charges. Okay, due to n number of charges here. Clear? So what we will write here, E1 is equals to what? E2 is equals to what? And lastly, En. I'm taking only two charges here, okay? So you know it is force divided by the test charge. And we know the formula for electric field intensity is KQ by R square R cap, right? We know field intensity is independent of the test charge. So we will just write the formula. It is KQ by R1 square, right? And this R1, this P point I'm taking because the test charge is placed at the point P, right? So this is R cap 1 P. Similarly, this is KQ1, okay? This is KQ2, this is R2P square, R cap 2P, and this would be KQN by R NP square, R cap NP. Now, if you write the net electric field, it will be, I'm taking K common, right? Here you will have Q1 by R1P square, R1P cap plus Q2 by R2P square, R2P cap. And this way we'll have Qn by Rnp square, Rnp cap. Clear? This is what you will have. Now, when you will use the superposition principle, this K is what? 1 by 4 pi epsilon naught, we know, right? And summation will be there. I is equals to 1 to n, because you are having only one Q1, this all the, because P point, okay, this charge will be constant, the same charge for all. Okay, so here what you will write, this is Qi, because I will be equals to summation, I will be from 1 to n. And here you are having Qi by Rip square R cap Ip. So this is your formula for electric field intensity using the superposition principle. So this is how you can calculate. So once you understand the superposition principle, it's very easy for you. Okay, so that's all in this video. Thank you so much. Have a good day.